All right? So if you'll turn in your handout to the trinomial factoring section. Anyone else need a handout on the trinomial factoring? All right. That's this handout. Trinomial factoring. If you don't have this handout, give me a call and I'll send you one. Okay? Now, the second type of factoring is the factoring of trinomials. And the prerequisite for this section is foiling problems. And on page 1 of this handout, I'd like to lift out 4 problems for you. On page 1 of the handout, I'd like to do x, number 1, which is x plus 2 times x plus 5. Number 4, which is x minus 2 times x minus 5. Number 7, which is x minus 2, x plus 5. Number 10, which is x plus 2, x minus 5. Okay? Now, remember the word FOIL. This is a product of 2 binomials, and what I'd like to do is FOIL, in other words, take the first times the first, which would give you, what, x squared? And then we'll do the outer times outer, and the inner times inner. This is the f, and this is f. And then we've got the OI. Now what's the O and the I? 5x and 2x, which would be what? Plus 7x. And then the last times the last, which would be plus 10. So we've got F, OI, L. Remember, that's my 3-letter word, FOIL. F, OI, L. You don't think I'd be using 4-letter words in a math class, do you? Somebody said math is a 4-letter word. Any of you agree with that?
Yes.
Yeah, all right. All right, now, next problem. Oops, I forgot to put my L up here. Let me get the right color, L. All right, now, for the next problem, what would it be? F would be what? F would be x squared. O would be what? Outer times outer and inner times inner, which would be? Negative 5x and negative 2x, which would be a total of negative 7x. All right, there's the OI. And then the L part is going to be the last times last, which is negative 2 times negative 5, which is positive 10. Okay? The third problem down, number 7 in the handout, is the first times first would be x squared. And then what? Outer times outer, 5x minus 2x. 5x minus 2x would be what? Plus 3x. And then the last times last would be a negative times a positive, which is a negative 10. And the last one, number 10, first times first is going to be x squared. And the outer times outer and the inner times inner would be negative 5x, negative 2x would be negative 3x. And the last times last would be negative 10. All right? Everyone understand that? Now guess what we're going to do? Instead of this being the question and this being the answer, we're going to turn it around. Jeopardy style again. And we're going to erase this part of the board. Erasing this part of the board, then what I want to do is be able to go backwards on the problem. I want to know, what if this was the answer? What if this was the problem, and I want to write it in a factored form? Now remember what we said it means to factor. What does it mean to factor something? To express as a product. Is this a product? This is not a product, is it? This is a sum or a difference of terms. We want to express it as a product. So the first thing I want to do is just remember something about this. I remember that every one of these problems over here started off with what? 2 sets of parentheses. In other words, every one of them was a product of binomials. Every one of them was going to be the product of 2 binomials. All right? Now, also, you probably remember that little 3-letter word that I was talking about a minute ago. What was that 3-letter word? F, O-I, whoops, O-I, and then what? L. And now what? We're going to change this thing. We're going to have to rework this thing and kind of do it backwards. But we start with F. Start with the F part, and what we have to have is the first times first. Now that's the easiest part. Everybody's going to get that right. What's the first times first here? X times X. Okay? Every one of them is going to be X times X, isn't it? Because in every case, it was the first times first is X squared, which is going to give you X times X, X times X, X times X. So we got the first part. That's no problem. But the problem comes when we try to figure out what this other number is going to be. Now, after you do the first part, the first times first, when we're trying to factor a trinomial, let's do the last times last. You have to skip over the OI part and do the last times last. So in other words, this is going to be FL, L. In other words, I've got to find 2 numbers whose product is 10. You see this? What 2 numbers' product is 10? 2 times 5. Now, did anybody think 1 times 10? What if I put 1 times 10? Would that give you 10 for the last times last? Yeah. It would, but it won't work in this case because we also have to do the OI. After the L, after you get the L, the last times last, you have to switch to the outer times outer and the inner times inner. And see if that works out. Now, if I did this, what would be the outer times outer and the inner times inner? That wouldn't be 7, would it? So you were absolutely right. You should have said 5 times 2. 5 times 2. Now, can you add that together and see if it adds up to 7 for me? Does it? The outer times outer would be what? 2x, and the inner times inner would be 5x, and that adds up to 7x, and so that's right. Make them both plus signs to make it work, all right? What if you put this thing backwards and put x plus 2 times x plus 5? Would that be okay? That you put it in the wrong order? Is there a right order and a wrong order? No. Any order you put the factors will be fine. All right? Now what about the second example? What I need to do here is have first times first is x squared, that checks. Now to get the last times last equaling 10, I want the last times last to equal 10. What would that be? Again, 5 and 2. But what's the difference here? 5 and 2, we need to make it add up to a -7. You see what I mean? We've got to make it add up to a -7. All right? Make it add up to a -7. And the way we do that is by making it, to get a positive 10, you see, it could be a positive times positive, or what else could it be? To get a negative times a negative would give you a positive. So let's make that a negative times a negative, which would still give you positive 10. Okay? And both of them be negative. And that would check because the outer times outer is -2x, and the inner times inner is -5x for a total of -7x, right? All right, let's try the -10. What would you have to do to get a -10 in here? What does this negative sign right here tell you? It says you'd have to have what? A positive times a negative or a negative times a positive. So the signs are going to be opposite. If this is a negative, the signs are going to be opposite. So let's do that. It would be 5, 2. Now, which one do you want to be positive if you want it to add up to a positive 3? Make it a positive 5 and a -2. You see that? Because if I do this, I'll have for the outer times outer a -2x, for the inner times inner a positive 5x, and that would be a total of 3x. Total of 3x. Now, for the last one down here, it would have to be a 5 and a 2 again. And let's make this a -5 and a positive 2. Okay? Right, now that's probably all you can handle in the way of explanation right now, so this is a good place to stop and do a few problems. like to give you a few more examples of this factoring concept. Hopefully you've been able to get a few examples yourself from the handout. And I think the handout is laid out in a way that you can, with a little bit of help, understand the concept. I might recommend this is a good place to have somebody looking over your shoulder, because I noticed as I stopped and went around and helped you, you caught on right away. You just needed somebody to help you get started, like I did on the first part of this video, right? Okay. Now, take, for example, on page 3, a problem that we haven't done before. In other words, you don't know the answer to this going into it, like number 13. Number 13, it says x squared plus 13x plus 40. Now, what's the three-letter word that you have to remember for this section? Not foil, but flowy. You've got to change the order around, remember? You have to do the F, and then the L, and then the OI. So what's the first thing I look at when I see that problem? F. And that means I've got to have two sets of parentheses here, and the first times first is going to be what? X times X. X times X. And then what would you do for the last times last? The last times last. See, after we do the first part, x times x is x squared, we immediately jump to the last, which is 40. The last times last has to be 40. Now, what times what would be 40?
5 times 8.
5 times 8. Some of you come up with that so fast. 5 times 8. It's like you almost knew what it was before you started. 5 times 8. Now, how do you know that 5 times 8 is actually the right number combination?
Because added together they
Okay,
equal 13.
added together, this outer times outer would be what? 8x. And the inner times inner would be 5x. And if we make them both positive, then it'll come out to the right number, 13. So the first thing you have to do is get the right combination of numbers. I want to show you a way that you can get all the combinations of 40. Break down 40 and just make this little list of numbers off to the side on the 40. 40. Start with 1. 1 times what?
40.
40. All right, 2. Does 2 go? 2 times 20. How about 3? 3 doesn't go.
4 and 10.
3 doesn't go, does it? 4. Next would be 4. 4 times 10. By the way, can your calculator help you with this?
Yes.
Yeah. How do you know? Take 40, divide by 3. If it goes evenly, you know it goes. If it doesn't go evenly, you know it doesn't go. And then how about 5? 5 times 8. And then what would be next? 6 doesn't go. 7 doesn't go. And then 8. 8 times 5. That means we've got all the combinations. All right? Now, suppose I change this problem to a negative. Let me start over with a new problem using 40. All right? What if I told you the problem is x squared, and then let's say x squared plus 18x, and then minus 40. What if I said it's x squared plus 18x minus 40? Now, what does this tell you? First thing you look for is the two sets of parentheses, which would be what? First times first is x times x. Okay? Now we're looking for the last times last, and this time it's a negative 40. Now, what's the significance of that negative on the negative 40? It means the signs are going to have to be different. Opposite signs, right? Use the opposite signs. So in other words, you'll have to use opposite signs. That means one of these is going to be a negative and the other is going to be a positive. Now look at these. If one of them's positive and the other's negative, imagine this now. What are we going to actually be doing if one of them is negative and the other is positive to come up with 18? Subtracting the numbers, you see. That's the thing we're going to have to do. If this is a plus number right here, the last is plus, then we're going to have to add the numbers together to get that right number in the middle. And if it's a minus, then we're going to have to subtract the numbers. So what would you say? It's going to be a minus, let's see, we'll have to have what two numbers that you can subtract and end up with 18. Which combination is it going to be? The 2 and the 20, okay? Does it matter whether I put the 2 or the 20?
No.
Doesn't matter, does it? So this will be what? 2 and 20, or 20 and 2. But which one gets the negative sign? Which one gets the positive sign first? The positive is going to be the 20, right? The positive 20 and the what? Negative 2. The positive 20 and the negative 2. Any questions on that? All right, it's time to stop and let you do some more problems on this then. All right. All right, now that you've had a chance to work a few of these problems from the handout on problems 1 through 90, are there any questions on problems 1 through 90? Let me do a couple of them with you to make sure you've got the idea. Any questions on the handout? Yes?
Is there an easy way to do this?
Is there an easy way to do this? Well, let's see. I think there is. I think there's an easy way to do this. Give me a problem. Give me an example of one of these problems.
42.
42. All right. Number 42. And in the handout, number 42 is at the bottom of page 4. It says x squared minus x minus 20. All right. There's this little 3-letter word that we had. Does anybody remember what that little 3-letter word was?
Oh, yeah.
All right, the first three, there are really 2 3-letter words. The first 3-letter word is the word foil. F, and then what? O-I, and then L. F-O-I-L. Now, everybody's familiar with foil, right? You're able to do foil inside and out, backwards and forwards. You're really good at foil now. That's what we're assuming. If you're not really good at foil, then you go get really good at foil, and then we'll come back and do the next step. All right? Now, if you're really good at foil, then the next thing we need to do is turn this around, change the direction of things, change the order of this, and put what? F, and then what? L-O-I. Now, why are we making it F-L-O-I? Because we're kind of going to have to do this differently. We're going to assume that this is going to be 3 terms, and if it factors, we're going to have 2 sets of parentheses. So we can start off with 2 sets of parentheses like that. Now then, the F tells you what? F tells you first times first. Now this is the easy part. Everybody can get this. The first times first would be what? X times X. Okay, now what comes after F in flowing? L. So we have to go for the last, L, which stands for the last times last. So I need 2 numbers whose product is what? See, this is the last. This is the F. The F is the x squared, and the L is the 20. So I need 2 numbers whose product is 20. Can you think of 2 numbers whose product is 20? 5 and 4, all right? Now, is there any other number that would give you a product? Could be 2 times 10. Now, if all you were looking for is 20, it could be any of several different numbers. And there's a way to get all the possibilities. What is that way? List them out here. Start with, let's say, 20. Now, 1. Start with 1. 1 times what? 20. 2. 2 times 10. 3. Doesn't go. 4. 4 times 5. And then 5 times 4. And that means you've got all the possibilities for 20. Now, it has to be a negative 20. So let's look at that negative sign now. The negative 20. What's the effect of that negative 20? What would it take when you multiply 2 numbers to get a negative 20? They have to be opposite sign, don't they? 1 positive, 1 negative. So that tells you they're going to be opposite signs. So on these numbers, it would have to be like a -1, +20, or +1, -20, or some combination of positive, negative, and what do we have to do with this to get the OI to match up with what it is here? The OI is going to be the -1. See, this is the F. The F is the x squared. The OI is the -x, and the L is the -20. Okay? So I need to get two numbers whose product is 20. That would be one of these pairs of numbers that you can add it up or subtract it. Now get this, it has to add or subtract to give you -1. Which of those is going to work? And would it be adding or subtracting? How do you know if it's going to be adding or subtracting to give you -1? How do you know if it's going to be adding or subtracting? If these are opposite signs, you're going to subtract. And if they're like signs, you're going to add. So in other words, if this is a negative sign, then we're going to have to subtract the numbers. Okay? Subtract the numbers, subtract which numbers would you say? The 4 and the 5? That's the one everybody gave you a few minutes ago. The 4 and the 5, that was what everybody gave me, 4 and 5. So let's make that what? A 5 here and a 4 there. Does it matter where I put the 5 and where I put the 4? Doesn't matter. But now which one has to be negative in order for it to add up to -1?
-5.
-5 and +4. All right? Now that was a very long explanation of that problem. When you get going on these, it won't take nearly that long.
I wish.
You wish. I promise. When you get good at this, it won't take nearly that long. Is there any question on that one? I think, okay?
Is it just because where the 5 is, because it's in the first set of parentheses that it's negative?
That's right. The 5 gets the negative. I know what you're...
If my 4 was there,
All right.
my 4 would be negative.
All right? No, let's try it. Now, if you put... Now, another way to write this would be with the 4 and the 5 back here. Put the 4 up front and the 5 in the second position. Now, which one gets the negative in order that it would add up to a -x?
And 5.
The 5 gets the negative. So now you get the negative here and the positive here. That would be okay, wouldn't it? In other words, this is an equivalent answer to this because the order's just switched around. By the way, what property is it that allows you to say this is the same as that? Switching the order? Commutative for which? Multiplication. Commutative for multiplication. Okay, good. All right, any question on that? All right, let's try another one. I need another example. Somebody give me a problem. Anybody have a question?
Number 3 on page 8.
Number 3 on page 8. All right. I haven't explained that one yet, but I don't think I have. But is there any other question on the first 90 questions? Otherwise, we'll go off into number 3 on page 8. Okay?
Yeah, I've had
All
two
right.
people ask me about when you have a positive and a negative,
Okay.
or two negatives, or two positives is obvious. Is there an easy way to tell what you're
All right. Let me come up with a problem for you then. But before we get into that next group of problems, let's take a look at number 18 on page 3. Page 3, number 18. It says x squared plus 17x and then plus 72. I want you to notice how I've color-coded this problem. I remember to color-code this one. The x squared term is in blue. That's to help you remember that's the first times first. Yellow to make you remember that it's the OI term. And then the last times last is 72. And I put that in pink. So what do I have to do here? Remember that it comes out with 2 sets of parentheses to start with, doesn't it? Then what? What times what? That's the easy part. Everybody can get that in a hurry, okay? X times x. Now, what's the next number you'll look at? See, we went first times first, xx, and then we skip over this 17. Skip over the 17, because the next thing you need to look at after the first times first is the last times last. Remember, the first times first, and then the last times last.
Yes, but then
Okay.
again, the sum of those two numbers has to equal the middle.
That's correct. That's correct. But we don't worry about that yet. You're looking for, right now, you got the x times x, okay? Now, forget about the 17 for now. And go to the 72. Here's what we want to work with. We want to work with 72. All right? How can you break down 72 in such a way that it will, what times what would give you 72 in such a way that it'll come out to 17 in the middle? 9, 8. 9, 8. 9, 8. Now, the fact that, what I want to talk about with this problem is this plus sign right here. What does that plus sign tell you? This plus sign right there, that plus sign tells you something about the two numbers you're going to multiply together to get plus 72. And what is that?
The vote's gonna be positive.
They're both going to be the same sign. They're going to be both positive. So in other words, if this is a positive sign, then these signs are going to be the same sign. And if this is positive, they're going to both be positive. And if this is negative, what are they going to be? Both negative. All right, so if this is plus plus, then this has to be both positive. Okay? Okay, and then you can see what the numbers would be. What, you said 9 times 8. And you see now the outer times outer would be 8x. And the inner times inner would be 9x for a total of 17x. All right? What if I made that problem x squared minus 17x and then plus 72? What if I made it that? Then I would have to have two sets of parentheses. And now what does this plus sign tell you? Signs are the same. The plus sign here tells you signs are the same. And what does that minus sign tell you about those same signs? They are both negative. So this will be a negative, negative. And of course, you already know it's going to be XX, don't you? Okay? And now, same sign means we're going to have to add these numbers together and get 17. And the numbers are same as they were before, what?
Except negative
Okay, except negative. It'll be 9, negative 9, and negative 8. Whoops, wrong color. Sorry about that. Any questions on that? All right, let me take another problem with a negative sign at the end. Now, let's do this one. If it's x squared, and let's say, I'm going to have to change the numbers here. I can't use 17 with the minus sign because it isn't going to factor if I... By the way, not every trinomial factors. I may not have made that clear. In fact, did you notice that every problem in the handout, it factors? Would that make you believe that every trinomial factors? No. Do you know we work very hard to make these come out so they factor? They are what we call in math contrived problems. We make them up so they factor. So if I just took, what, plus 17x, and then made this a minus 72, if I just change the signs and say, okay, now what's it going to be? Two sets of parentheses, and now what times what? XX? And we need two numbers whose product is negative 72. You know what? With this 17, it probably won't work out. If I just make up numbers, it probably won't factor unless I just got lucky. But now, because I am able to make up my own problems, let me just make it plus 1x. Would that be all right? Plus 1x. You see, I have to plan this ahead. I can't just throw numbers up here on the board. So if I make that a plus 1x, what do I have? Last times last would have to be 72, What's the effect of this negative sign right here? That's what we were talking about, the effect of this negative sign.
Here.
That means you're going to have a positive times a negative. That says the signs will be opposite. The signs will be opposite. And if the signs are opposite, instead of adding the numbers, what are you actually going to be doing with the numbers? Subtracting them. Okay? So what number do you think we're going to be working with here? We've been working with 9, 8.
We're going to have a positive
9. Okay, we're going to be working with the 9, positive 9. Positive 9, you see that? And a negative 8. A positive 9 and a negative 8. Now, when you do the last times last, it gives you negative 72, doesn't it? And for the outer times outer, you have a negative 8x. For the inner times inner, you have a positive 9x, and the answer would be positive 1x in the middle. That's correct, isn't it? That's exactly what you needed. Okay? Any question on that? Yes?
Is there any rule about when you have a positive and a negative, is there anything that you should follow to be consistent? Like always put your positive first or always put your negative first?
Always put the positive on the largest outer, inner combination. You calculate the outer times outer and the inner times inner and decide which of those is larger. Right, so this is what? 9x, and the inner times inner is negative 8x. And which of those is larger? The 9x. So that gets the plus sign. Okay? Very good. I'm glad you asked that. That helps. Now, suppose I change the problem and make it x squared. Suppose I make it x squared minus 1x and then minus 72. Okay? Where it's a minus here and a minus. All right, now what does that tell me? I've got to have two sets of parentheses. I start off with xx. Everybody gets the xx in a hurry. And I got to do the last times last. Now it's a negative 72. What does negative 72 tell you? Negative 72 tells you that it would be the opposite sign, doesn't it? The negative tells you opposite sign. So we'll go with what? 9, 8? Go with a 9, 8. Okay? And if it's a 9, 8, now figure the outer times outer and the inner times inner. The outer times outer is what? 8x. The inner times inner is 9x. So which of those combinations is larger? The 9x or the 8x? The 9x is larger. So which one gets the sign? The negative is going to go with the 9. The larger is going to get this sign. The larger of the combinations, outer, inner, is going to get the negative sign. And then this would have to be a plus sign. Is that right? Okay? So maybe that'll help some. All right, now let me move to the second phase of questions, the second phase of the handout. And this second phase is what I call the factoring two-step. Okay, the factoring two-step, I call it that because in these problems there will be two steps in order to get the problem factored. And I'm now on page